Now, so far, all the games we've seen have had a dominant strategy. Actually, that's not true. We did see that one game with Iggy and Azalea that had no Nash Equilibrium, no dominant strategy. We saw that if both players have a dominant strategy, when they do both have a dominant strategy, there is a Nash Equilibrium. It's the dominant strategy Nash Equilibrium. But in many games, neither player has a dominant strategy. And in some cases, there is either no Nash Equilibria or there can be multiple Nash Equilibria. Okay, so here's a game, a sequential game that has no dominant strategy or Nash Equilibrium. So we can see that Joey has a choice to hit to the left or hit to the right, and Rachel has a choice of guessing that he hits to the left or guessing that he hits to the right. So if she matches him, right, if he hits to the left and she guesses to the left, she wins the point, right? So if she matches him, she wins the point. If she doesn't match him, she loses the point. Okay, so there's no dominant strategy for Rachel, right? If Joey hits to the left, she wants to guess to the left, but if he hits to the right, she wants to guess to the right. So she doesn't have a dominant strategy, right? Her best choice depends on what Joey does. And same thing for Joey. If Rachel guesses to the left, he wants to hit to the right and win the point. If Rachel guesses to the right, he wants to hit to the left and win the point, right? So again, there's no dominant strategy here. So we would basically end up just with an unstable game. There's no stable outcome. Okay, so here's an example of a game that has two Nash Equilibria. Actually three, but we won't. One of them's called a mixed strategy Nash Equilibrium. We won't get into that. That's for a more advanced course. But in any case, this game has multiple Nash Equilibria. Okay, so here we've got Romeo and Juliet. Romeo prefers the ballet. Juliet prefers the football game, but they want to choose the same event because they love each other and want to be together. Okay, so let's start off and see what their best responses are. So let's suppose Juliet chooses ballet. Well then, of course, Romeo also wants to choose ballet. It's his favorite, and he wants to be with her, so that's his best outcome. He would be the worst off if he chose to go to the football game when Juliet went to the ballet. He would go to his least favorite thing and also not be with his love. So if Juliet chose ballet, he'd want to choose ballet. If Juliet chose football, then in that case, Romeo would want to also choose football. So basically, they want to match each other, right? And it's the same thing for Juliet. If Romeo chose ballet, she would prefer going to the ballet rather than going to football. And if Romeo chose football, she would prefer to choose football rather than to go to the ballet. Okay, so basically, right, so there's Romeo's best choices, there's Juliet's best responses. And so since we've got two circles here and two circles here illustrating our best responses, these are our two Nash Equilibriums. So we've got two Nash Equilibriums here, and it's basically they go to the event with each other, regardless of whether it's ballet or football. But of course, Romeo prefers the ballet again, and Juliet prefers the football. Okay, let's wrap this up with just a little bit more practice. So how can a pure strategy Nash Equilibrium be accurately described? By the way, pure strategy, so we didn't talk about this, but a pure strategy just means that you choose with 100% certainty one of the strategies, okay? This is opposed to a mixed strategy where you randomize. You basically like flip a coin or roll a dice to determine your strategy. So pure strategy just means you pick a strategy with 100% certainty. So you can actually kind of ignore that. You don't really need that to answer this question, but take a moment, pause the video if you need to, and come back for the correct answer. Okay, so hopefully after thinking about it for a second, you realize the correct answer was B. Recall that a Nash equilibrium is one in which neither player has an incentive to deviate or change their strategy. It is not necessarily the best outcome, as we saw with the prisoner's dilemma. And it doesn't necessarily have to be reached by collusion. And of course, we just saw an example where there are multiples, so there's not necessarily only one. All right, here's a chance for you to practice solving your own game table. So based on the table below, which outcome reflects the dominant strategy? So this is a dominant strategy question. You don't have to necessarily find the Nash equilibrium, although you could probably easily figure it out once you find out the dominant strategies. So take a second and pause the videos and find the dominant strategy Nash equilibrium. Okay, hopefully after a little bit of thought, you realized that for savory sandwiches, its best choice, its dominant strategy is to charge 2 for 1, right? Because regardless of what University Subs does, 1,000 is better than negative 5,000 and 15,000 is better than 10,000. So they have a dominant strategy of offering 2 sandwiches for the price of 1. And as it turns out, this is a sequential game, so it's the same for University Subs. 1,000 is better than negative 5,000 and 15,000 is better than 10,000. So they each have a dominant strategy of choosing 2 for 1, and because of that, the top left here is the dominant strategy Nash equilibrium. All right, so in conclusion, we see that oligopoly is a market structure where there's relatively few firms, a lot fewer firms than either perfect competition or monopolistic competition. And because of this, firms interact strategically. There's some mutual interdependence going on. But we learned some interesting things with regard to duopoly in particular when we looked at duopoly. It turns out that a duopoly can actually end up at the competitive outcome where prices are equal to marginal cost. So that's pretty interesting. Overall, oligopolies can be competitive. Results tend to be closer to monopolistic competition, but they can also sometimes successfully collude and form cartels and achieve outcomes that are closer to monopoly. So I hope you enjoyed this lecture. This will be the conclusion of the material you're responsible for the semester. We will look at one more chapter, that's chapter 7, which has to do with public goods and externalities, but that chapter is optional. So you don't have to do it if you don't want to. It won't be on the final exam. However, there will be a pre-lecture, post-lecture homeworks and a quiz as well. And if you complete those, any one of those, I will basically drop your lowest grade in that category. So if you complete the pre-lecture homework for Chapter 7, I will drop your lowest pre-lecture homework grade. If you complete the post-lecture homework for Chapter 7, I will drop your lowest post-lecture homework grade. If you complete the quiz for Chapter 7, I will drop your lowest quiz grade. So if you have some low grades in any of those categories, you may want to do the optional assignments. But again, Chapter 7 will not be on the final. So this is the conclusion of the course material. I hope you enjoyed it. I'll see you in the next video lecture for those of you that choose to watch the video lecture for Chapter 7.